Assalamu alaikum dear students. I hope you all are doing good with your A-level physics. Right now we are here with end of chapter question, accelerated motion question number 13. It is a totally hot air balloon scenario. It is basically a very simple case of the projectile motion. Here you have that hot air balloon rises vertically at time t equal to 0. On the very starting time, the ball is released from the balloon. Okay, so just imagine that it is a hot air balloon, and here the people used to sit, and this is the helium balloons we have seen, and in this balloon a small ball is released into the air. Okay, a small ball is released into the air. Here you know that the projectile motion, this ball will go rise up. Okay, and after it will reach the maximum height, it will go down. Okay, so here you know that the positive direction, the velocity by which the ball is going upward will be taken as positive v. It will be taken as positive v, and at the maximum height, the ball will reach the maximum height, the velocity will be 0. Okay, just keep in mind these points. This will help us to solve this graph. Okay, so when after coming downwards, the velocity will be downwards, or direction will be taken as opposite. It means we will take the negative direction of the velocity. When it is going downward, the ball velocity will be downward, so it will be taken as negative, and the ball will reach the ground ultimately. Okay, here the upward velocity of the ball is positive. At the maximum point, when the ball will reach the maximum height, the velocity will be 0, and when the ball will be going downward, the velocity will be taken as negative. Okay, so here it says that the VT graph is given for the ball, velocity and time graph is given. On the y-axis the velocity is plotted, on the x-axis the time is plotted, and it says that the ball hits the ground t equal to 4.1 second. It means this is the 4.1 second when the ball hits the ground. You see, when you go to the time axis, you see that it is approximately 4.1 seconds. So this is the time when the ball hits the ground. Now compare this scenario that the upward velocity will be taken as positive. I told you that upward velocity taken as positive. It means this is the velocity with positive, it is above x-axis. It is positive v. Above 0 it is positive v. Below 0 it will be negative v. Okay. Also you know that at the maximum point the velocity will be 0. So here you see that the velocity, it touches the time axis, therefore the velocity of the ball is 0. Okay, and after, from here the ball will go down. Okay, after this the ball will go down. After the graph touches time axis, that is the velocity becomes 0, and after the velocity becomes 0, the ball will go downward and will touch the ground. Okay, so dear students, the first part A asks explain how the graph shows the acceleration of the ball is constant. Okay, so we know that the gradient or the slope of the VT graph is acceleration. Okay, it means divide the value of velocity by time. We know, of course, the acceleration is basically velocity, change in velocity divided by change of time. Okay, so somehow if we can prove, or from if we take any 2 points on this very line, and we can have velocity difference on the upper side and time difference on the denominator side, and we if we divide both of them on each and every point, the acceleration value is same, so we can say that the acceleration of the ball is constant. Okay, just take any 2 points on the graph, and after that we can say that the acceleration is coming constant or not. Okay, just took this point, choose this point and choose these 2 points. Okay, this point is 0, 15. I'm talking about this point, and the second one is and this one is this is 0.5 on x-axis, and time is 10. So by using these 2 points, we will find the gradient or the slope of the given line. And okay, so now you know that we are taking the point as t and v. Okay, so t as x and velocity on y axis. So we will find the acceleration as 10 minus 15. We will have 10 minus 15 divided by 0.5 minus 0 equal to minus 10. It means that the acceleration is minus 10 meters per second. So whenever you will take any 2 points on this line, like this, I have taken the 2 points, either you take this point and this point, okay, or this point. So this is how we can say that the acceleration of the ball is constant, because we have find acceleration from taking multiple points. Take any 2 points on this line and change of velocity as numerator and change of time as denominator, and you will get minus 10 or near to minus 10. So it means the gradient or the acceleration of the ball of using this graph is constant. Okay, this is how the first part will be. Okay, now the second part says that determine the time at which the ball reaches the highest point. Okay, you know that we have just explained the scenario that whenever the ball will go to the highest point, then the velocity will be 0, okay, at this highest point. So just check on this graph that when the velocity will be 0, highest point will be when the velocity will be 0, okay. So just check this when the velocity graph touches time axis or the x-axis. At this point the velocity is 0, okay. So check the time here is approximately t equal to 1.6 second, okay. So this is the answer for part B. Okay, so we have for t equal to 1.6 second. Okay, now for part 2, show that the ball rises for a further 12 meter between release and its highest point. It means, in other words, they are telling us that find the distance, show that the distance should be 12 meter. Just remember, show that the distance is 12 meter traveled by the ball between the release and the highest point, okay. So you know that area under the curve, that is the VT curve, is the distance, okay. So we need to find out the distance between the release and the highest point. Okay, we need to show that the distance of the ball traveled is 12 meters between release and the highest point, okay. So when the ball is released, the time is 0, and when the ball is at the highest point, the velocity is 0, okay. So we need to find basically this area of the shaded region, basically this shaded triangle. When we will use when we will find this area, we will get the distance, okay. So we know that the area of triangle is half base into height, okay. So you know that it is half base is you know it is 1.6. So base is 1.6 multiplied by the height of the triangle. Height of the triangle will be this you know it is 15. So when you multiply this half multiplied by 1.6 multiplied by 15, you will get approximately 12 meter. That is, we have shown that the area, that is the distance the traveled by the ball from the time of release and the time till it reaches the highest point, that is 12 meters. Okay, and now for the third part, it says that find the distance between the highest point reached by the ball and the ground, okay. It means that the highest point reached by the ground will be this, and the time when the ball reaches the ground will be this. So we need to basically find the area of this triangle, and when we will find the area of triangle, then area of triangle will be the distance. Okay, so area of triangle is, again we have half multiply by base multiply by height. Okay, and here again half. Base is what? Base is 4 point. Okay, so this is 1.6 and this is 4.1. Okay, so basically we need the length between these. It means 4.1 minus 1.6. This will be 4.1 minus 4.1 minus 1.6 and multiply by the height. Height will be, height is this. Height is basically minus 25, but as far as we will see, the displacement is minus 25, but as we do just need to find the distance. Okay, so distance is a scalar quantity, so we will only take not we will take minus 25, because the here you see it is minus 25. We will take only 25. So when you will multiply this, you will get area or the distance, because area under of the curve, that is the VT curve, is always the distance. It will be 31.87 meters. This is the distance traveled by the ball between when it is at the highest point until it reaches the ground. Okay, hope you are getting my answers. Okay, now in part C they are saying that the equation for the VT graph is this. It means that for this VT graph they are giving this equation, and now they are asking that what is the significance of the equation. It means there are a lot of attributes in this equation, so they are asking that in part 1, what do you mean by the number 15 and what do you mean by the negative sign. For the dear students, you can have that when you will get this number 15, basically when you will place here t equal to 0. Okay, it means the starting or the initial speed of the ball. When you place t equal to 0, here we only have v equal to 15. Okay, because minus 9.8 multiplied by 0 is 0, so we will get velocity 15. That means that this 15 signifies us that it is the initial speed of the ball. It is the initial speed of the ball. Okay, and also we have they are asking for the negative sign, that why this equation contain the negative sign. So we will say that acceleration due to gravity, this negative sign is as acceleration due gravity, and the ball is going upward. Okay, ball is going up, ball going upwards, and always the gradient is negative. The gradient is always be negative. Okay, because it is minus 9.8. The ball is traveling against the gravity. We take minus 9.8. So hope you are getting my point. Do like, share, and subscribe my channel for more A-level videos, A-level maths and physics videos. Thank you.